Latitude Media, podcast at the frontier of climate technology.
I'm Shayle, and this is Catalyst.
We could have avoided this. We could have gotten in front of it, and we could have seen that, boy, oh boy, distribution transformers is going to be a pinch point.
Listen, I'm just going to be brutally honest. If you haven't had a conversation about transformer lead times in the past 2 years, do you even electricity, bro?
Let's face it, environmental news is often very depressing. That's why we focus on solutions on this podcast. But still, the climate crisis looms large. Rising temperatures, mounting pollution, environmental degradation, they're all warping the planet. And for a lot of species, including us, things don't always look so great. But the story doesn't end there. Every Friday, Living Planet, a show from Deutsche Welle, takes you behind the headlines to figure out what's happening and how we'll get through it. It'll also help you make better choices for a healthy planet and find space to reconnect with the beauty and wonder of the world around us. You can find Living Planet wherever you get your podcasts.
I'm Shayle. I invest in revolutionary climate technologies at Energy Impact Partners. Welcome. Well, I have been wanting to do this one for quite a while. You remember when, in the midst of COVID, the world's supply chains all got gummed up and lead times for basically everything grew, supply chain prices were elevated. It was like really painful across a variety of different industries. And then, as they do, the supply chains more or less cleared and things kind of went back to normal and we resumed everyday activities. Except if you were trying to buy electrical equipment, specifically and especially transformers, they did not. Transformer lead times have remained extraordinarily high and in fact have generally gotten worse since the problem started in 2020. By some estimates, we're seeing up to 100-week plus lead times for some power transformers, 2 years, maybe even up to 125 weeks for things like generator step-up transformers. It's really wild. I've seen firsthand how big a problem this is. It's an issue in real estate. It's an issue, obviously, for utilities. And it's actually a really big issue for many startups. If you need transformers, or if your projects are going to need transformers, and you have a 2-year lead time for those transformers, that makes planning on startup timescales extremely difficult. But why is it like this? Like, transformers don't inherently seem like the kind of thing that would face such a persistent shortage. So to try to make sense of it, I brought on Tim Mills. Tim is the CEO of a transformer manufacturer called ERMCO, and he's been at the forefront of this crisis, both challenged by it and benefiting from it to some extent, since it started. Here's Tim. Tim, welcome.
Shayle, good to be here. Thanks for having me.
Let's talk about what the hell has been happening in the transformer market, which is a lot, as I understand it, but starting with breaking down the transformer market. Obviously, transformers are not one thing. We use them all sorts of different places across the electricity supply chain, the value chain. So give me high level how you think about the buckets of different types of transformers, and then where within those buckets have we been seeing the most stress in the past couple of years?
Yeah, great. Good question. And you know, from the power generation plant to the endpoint, there's a handful of places throughout those power lines where you're going to see different transformers. I like to think about it as really starting right at the power plant. Large power transformers are going to step up that generated power to an extremely high voltage. That's going to go on a transmission line. Ultimately, that transmission line is going to take it into a substation, step it down to a distribution voltage level, and then ultimately push that electricity down to a house or to a factory or to an apartment complex. And that's going to go through a distribution transformer, either a single phase or a 3-phase transformer. And in my opinion, I think that's really where a lot of the focus has been in the United States over the past couple of years, where the demand for that transformer has really shot up, and the ability for manufacturers like ERMCO to keep up has been extremely challenging.
So we'll talk mostly about that last mile distribution transformer because that's been where the challenge has been. So maybe take me back in history to before this current shortage. What was the norm? Like if I needed to order distribution transformers in the United States, what would that look like for me in, 2018?
Yeah, so in 2018, I think most customers, most utilities felt really, really comfortable with the distribution transformer supply chain. They'd pick up the phone or they'd shoot over a PO, and in anywhere from 12 to 14 weeks, that transformer was showing up on their doorstep. And if they were ordering 10 or 100 or 200, manufacturers were able to respond to it. But then something started to change, right? I mean, I think what happened was slowly, because of dynamics in the marketplace, the demand was rising much, much quicker than the manufacturing base was being able to produce additional output. And ultimately, we got to a point where we were at max capacity, but demand didn't stop there. It just kept on rising. So in the 2020, 2021 timeframe, things were getting really, really crazy, and lead times started jumping way out there. And I think it was causing a lot of concern and a lot of panic in the marketplace, because what used to be a pretty quick turnaround was now all of a sudden unpredictable. And even after a lead time was given, it was undependable as to whether the manufacturer would actually hit it.
And so where are we today? Like, what are current lead times for distribution transformers?
It's still really, really long. I mean, so I like to think about distribution transformers in three different flavors: a single-phase pole-top transformer, a single-phase pad, and then a three-phase transformer. Generally, those are pad-mounted transformers, but occasionally you'll see them overhead as well. The single-phase pole-mount transformers, the gray ones that are up on a utility pole, I think the supply chain there is getting closer to being caught up, right? And so lead times are normalizing. They still might be outwards of a full year just because of the backlog that was built. But I think supply and demand are starting to stabilize in that space. But those pad mount transformers, both single phase and three phase, still pretty darn long. I've seen things as long as 2 years right now on either.
I mean, just to contextualize that, you just said a minute ago that like in 2018, that was 12 to 14 weeks, right? So we're talking about in the better part of the market, it's maybe a year now, which is 4 to 5 times as long. And in the worst part of the market, it's maybe 2 years now. So 8 to 10 times the lead time, which is wild that that's lasted for, a couple of years now. Have you seen that? I mean, you've been in this business a long time. Like, have we ever seen lead times get that long, or this kind of a shortage? Or is it like a cyclical market that goes through these types of periods, or is this anomalous?
So, it's a really interesting question. I look back over history, right? And I tried to understand what are the fundamental demand drivers in the distribution transformer space. And there was a really strong correlation between volume output of transformers and the housing market, right? So those were heavily correlated. And so, yeah, you asked, has there ever been a time in history where lead times got that long? There was 2006 and 2007, where housing starts in the U.S. were, approaching 2 million a year. But then that housing market crashed. And of course, the need for transformers also crashed at that point in time. And I think that was the start of the change of the dynamics in the industry. I think that caused a lot of manufacturers to either exit the market altogether or certainly change their allocation of resource to production of distribution transformers. My gut tells me if you looked at the total capacity in the U.S. for building a transformer in 2007 versus 2021, it was probably constant. Well, what happened in that time period? The dynamics and the need to upgrade our infrastructure, the investment coming from the federal government, the electrification of everything, right? The advent of EVs and putting that on put a whole new strain on the supply chain that didn't exist 15 years ago. And I think it's those factors that caused the change in demand.
The way you describe it, I also wonder whether, in 2006 and 2007, sounds like demand shot upward because of housing starts and new housing. And then probably a bunch of manufacturers got caught flat-footed when the housing market crashed, would be my guess. So I wonder if there's a, fooled me once situation where anybody who has a memory that goes back that long saw the sort of build up in demand over the past couple of years, which we'll talk more about what caused that, but saw that and said, well, I don't know if this will be sustained. And so didn't ramp up manufacturing capacity as fast as they could have because they had learned the history of the housing crisis and and didn't want to get out over their skis. Do you think that's a possibility, or was this more of a like all hands on deck immediately and nobody could keep up sort of a situation?
Oh no, I think it's more the former than the latter. Than the latter. I think people certainly saw what was happening. I know, my company felt it. We saw the orders coming in faster than we could possibly produce them. So it'd be really surprising to me if people were totally flat-footed. It was like, well, what can we do about it in the short run if, in fact, this does not sustain for decades? Because at the end of the day, in order to change your output, it's not a flip of a switch. It's a tremendous amount of work or a tremendous amount of investment in order to make that happen. And I think most of us looked at it and says, boy, I don't know how to respond to what the market is telling me.
Yeah, so I want to get more into that because I think what happened was as the transformer market was starting to see this shortage and these longer lead times, that coincided with, it was in the middle of COVID and lots of supply chains got gummed up and lots of lead times grew for all sorts of things, right? And that turned out to be somewhat ephemeral in many markets, and things got back to normal in most markets relatively quickly. Freight costs went back down and so on, but the transformer market just stayed gummed up. And so there was something different going on there than what was going on in the rest of the economy. And I want to understand a little bit better why, starting maybe with the demand side, then we'll talk about the supply side. I mean, you said demand started rising in that period, 2020, 2021. Do you have a sense of why that is? I mean, it's not like new housing was shooting upward this time. And I think you could ascribe it to electrification, vehicle electrification and so on. But I wonder whether there was, enough to show for that already that you would have seen a change in the curve of demand for transformers. So how much was demand growing and do we know why?
Yeah, so I want to rewind the clock to 2020 and 21 for a second, because I think it's important for people to understand the initial reaction in the marketplace was that this was the COVID response. This was the inability of the manufacturer to produce as many transformers as they had been doing the year prior, right? This is the same thing that people were experiencing all over the United States and the world for that matter. But this was not the microchip problem, right? That was preventing automobiles from being produced, where literally you couldn't get the componentry, the necessary input to produce the output. This was the toilet paper example, right? Where people went to the stores in irrational fashion and demanded much more than what a Kimberly-Clark could produce, or whomever makes toilet paper. I actually don't know who those manufacturers are. And so what was happening in the transformer world is because going into COVID, people were getting those deliveries on a consistent basis in 12 to 14 weeks. They weren't placing their orders. They weren't getting in front of what their consumption was going to be from a utility perspective, because they didn't think they had to worry about it. Well, then as those orders started coming in and the supply and the lead times were creeping out, I think that was kicking out more and more orders. And so I think most people thought this was going to be pretty short-lived. But then the confluence of all of those other factors, macro factors, came into place. The infrastructure spending that was coming out of the federal government, certainly the electrification, more and more EVs coming into the market. And again, I think we'll probably talk about it a little bit later on what that does to a distribution transformer. Renewables coming onto the grid, right? We're trying to put a whole bunch more solar, a whole bunch more wind onto the grid. That's going to impact that final mile. It's going to impact the distribution transformer. And then finally, we haven't talked about it yet, but storms. We went back and looked historically, like what was the demand on a transformer because of storm response? And we recognized that the level of, kind of natural disaster from 2017 forward was much more severe than the level of natural disaster pre-2017. So now all of a sudden you have 4 or 5 different variables plus a more robust housing market, right? It wasn't back to the 2006 and 2007 levels, but it was more robust. So it was kind of a confluence of all of these factors coming together at one time. And it became overwhelming.
Okay, so clearly then what was happening was there was a sort of facade, a false sense of complacency in that 2020, 2021 period. Lead times are creeping upward, but that's happening in every sector. And we think, okay, maybe this is a COVID response thing and it's going to be temporary. So I don't want to overinvest in new manufacturing capacity and so on. Turns out it was sustained and demand has continued to rise for all the reasons that you mentioned. And yet, while all these other sectors have responded, we haven't seen it in the transformer sector. And presumably that is because despite now, I assume everybody has woken up to the fact that this wasn't a temporary phenomenon. For some reason, it must still be hard to expand manufacturing capacity. Otherwise, correct me if I'm wrong, we probably would have seen it already. So is that true? And if so, like what makes it difficult? Why haven't you been able to just double your manufacturing capacity to meet all this new demand?
Yeah. So again, I think I shared earlier, looking at it from ERMCO's perspective. And again, I believe most of the competitive manufacturers of distribution transformers would say the same. We kind of got to the point where we were saturated. We were at full output. We were at full capacity. Yeah, maybe we were operating at 92% instead of 100%. But as this demand started to grow, we were getting nearer and nearer to 100. So the ability to get that next incremental unit out became very challenging. We were already operating the facilities 24 hours a day, 5 days a week. So you had a little bit of opportunity if you could expand your labor force in order to get those extra 2 days of asset productivity, but challenged to do it in a very tough labor market. Particularly think back to the COVID years, trying to get people to go back into the office was difficult to say the least. And then you couple that with where most of the transformer manufacturing is happening out in rural America, smaller communities. There's just not a ton of excess labor sitting out there. I mean, again, look at unemployment across the United States right now, still very, very low. So being able to try to add a ton of people, and we're not talking a few, you're talking hundreds of people to get a new production line staffed, it's challenging. And then if you really had no equipment availability and you had to add a new facility or a new line, you're talking hundreds of millions of dollars, well, $100 million of investment in order to get that facility stood up. And then the lead time to get all of the equipment. And so you're talking a 1 to 2 year turn just to get starting with production. And then it's about ramping that facility up. It is not, it's like the Titanic. You can't turn it on a dime and the iceberg's right there.
What about, I know another factor that adds complexity to producing more distribution transformers in the US has to do with steel, a particular kind of steel and manufacturing capacity there. So talk to me about the interaction between steel and transformer manufacturing.
So if I think about the kind of the core, ironically, I use core,
in a literal sense,
yeah. The heart of the transformer is the core coil assembly. So it's the piece that takes the high voltage and it converts it to a lower voltage. So you have a coil winding that's slowly bleeding off the energy. I guess that's the best way that I would describe it. And then you have an electrical steel core that surrounds that coil to help generate the drop in voltage. It's a very specialized steel, and in the United States, there's literally one manufacturer that makes grain-oriented steel, and that's Cleveland-Cliffs. And their plant is essentially operating at 100% capacity. It's at 100% output. And so the ability to get more grain-oriented steel into the transformer market is challenged. Now, there's foreign sources of steel as well, and I know a lot of my competitors are using foreign sources of steel. The cost for that went up, right? There was tariffs put in place in order to, protect the market. I don't know why the tariffs were put in place, but there are foreign sources of steel. And then, of course, there's an alternate material that is becoming talked about a lot more in the industry, and that's amorphous steel. And again, similar to grain-oriented, only one manufacturer of that in the United States. So it's a pretty risky supply chain when it comes to the inner workings of a transformer.
All right. So if you're a distribution transformer supplier, you've got multiple issues. If somebody said to you overnight, which basically it sounds like people have, can you double your capacity? You got to spend a lot of money. You got to find a labor pool. you got to ramp it up. It's going to take you some time anyway. And then even if you do all that, you have to find grain-oriented steel, which you're going to have to probably buy internationally at this point and pay more for given tariffs in order to do it. Before we move on from steel entirely, you mentioned amorphous steel. There's an additional dynamic at play there, which has to do with regulation, right? And DOE is sort of stepping in on regulations regarding distribution transformers in a way that can impact our ability to scale up manufacturing. So how does that play in?
Yeah, regulation is certainly a factor right now, and it's one that's probably causing all of us to think long and hard about what investments we want to make and how we want to place bets about the future of the industry. So very specifically, I describe grain-oriented electrical steel to make the core of the transformer. Amorphous steel is an alternative to that. The difference between the two, I'm not going to get into the metallurgy of it, but the difference of the two is that the amorphous steel has properties that allows a lower loss of energy through the transformer, particularly when it's not at load. So those no load losses are much better with amorphous steel. And the implication there is if you had all of the transformers in the world with amorphous steel, then you're not going to you're not going to need to generate as much power in order to actually support the load that's happening, because we're not going to have as much inefficiency. So it's a raise in standards of efficiency that grain-oriented steel in its current form really can't keep up with. It's just not capable of doing it. The problem is I'm guessing 95 to 98% of all the transformers that are being produced in America are using grain-oriented steel. And for me to change the process in order to produce that transformer to incorporate the amorphous steel, it's challenging. This is a significant investment in capability, a significant change in process, and it's one that, in order to make the transition, it's going to take time. Couple that with getting a workforce to be able to work with a different process and a different material, I suspect you're going to see a drop in productivity, so a drop in output before you get any sort of learning curve and get back to stability or even get a little bit more efficient. So it's a really complex problem. But if you want me to expand my capacity today, well, what kind of equipment do you want me to get for my cores? I could get grain-oriented equipment or I could get amorphous equipment, and I don't know where to make my investment.
And talk a little bit about the role of regulation there. Like, what is DOE proposing?
DOE is proposing a higher efficiency standard. As a matter of fact, if their initial proposal were enacted, essentially it would eliminate the need for grain-oriented steel. It would make it impractical to build a transformer using grain-oriented, and we'd have to switch to amorphous. I'll dismiss for a second the problem that there's not enough amorphous in the world to make all those transformers with it. But if there were, we'd still have to change our entire manufacturing process in order to be able to incorporate it into the production cycle.
So there's some risk if that goes through, what is already a challenging supply chain gets a whole lot worse.
That's exactly right. Now, the Department of Energy asked for public comment, and I think there was enough out there and enough concern expressed that I suspect a compromise position is going to come out. I don't think what they had originally released will actually become the new standard. Most recently, Senators Brown and Cruz had put forth legislation that would suggest that we're going to do a stay or we're going to hold current standards for a period of time. That certainly would provide a little bit of relief for manufacturers. But I think in the next 1 to 3 months, the amorphous debate will be put to rest. We'll know exactly what we need to build for. And, America rises up to a challenge. So we're going to figure it out and we're going to end up coming up with something that's going to work. But for right now, there's a lot of uncertainty and we have to just wait for that to get clarified.
We've talked about lead times. We haven't talked about price. One presumes that in a supply-constrained market with increasing lead times, you would also see increasing prices. Can you talk about what price trends have been like for distribution transformers? And maybe to the extent that you have visibility into this, like how big a deal does that end up being for those end customers, right? Or for, I guess, utilities who are having to pay for them?
Yeah, so pricing has increased a lot over the last couple of years. I would say on average 75 to 100% increase in price. I would say the last 2 years, so 2023 and going into 24, much more stability, maybe a 5% increase in 23. Right now, I'm projecting a flat to a 5% increase in 2024. So we're getting a little bit more stability now. I'll tell you that the customer base, the utilities, it's painful for them, right? Because it's costing them a heck of a lot more to put these transformers onto the grid. They have to then go ahead and get, they're going to have to get reimbursed from that through the ratepayer, right? The consumer, you and I. Shayle, we're the ones that are going to ultimately pay the bill. And of course, they're going to their regulators to get changes to rate cases that sometimes are being pushed back on. So it's causing a little bit of angst in the marketplace right now, but it's really tough, right? Because as I'm seeing increased costs on electrical steel, on oil, on copper, on aluminum, I have to pass that on, right? I can't bear the cost of that all as a manufacturer. And so most of the increase has really been nothing more than a pass-through of commodity prices and, of course, wage pressure for our workforce.
All right. So we're, I don't know, call it 3, maybe even a little more than 3 years into this current cycle where lead times have increased and prices have increased and so on. What's the prognosis? Like, are you working to expand manufacturing capacity despite the time that it takes and all the challenges? Is everybody else? And are we going to see this, are we going to break the back of the supply chain bottleneck in the near term? Or do you think this is kind of just the new normal?
Again, I said it earlier, America rises to a challenge, and I think that's going to happen in this industry as well. I know there's been a lot of announcements over the past 12 months in terms of expanding capacity in the transformer market, on the single-phase side, on the three-phase side, and I do think that's going to bring some relief. My company completed a major acquisition at the end of 2022. We saw a business out there that we thought had a lot more runway in terms of expanding output than the legacy ERMCO business did. And we're watching that come to fruition right now. The two companies had 1 year together. In 2023, we drove about 85,000 additional transformers out the door in that 12-month period prior to the, over and above 2022. And we expect to see an increase similar to that going into 2024. So I think there's a lot of movement to get the problem fixed, to close that supply and demand gap. I could tell you that's the number one focus of my company. And again, I think the competition is doggedly focused on the same. So I do see relief in sight. I think the single-phase pole problem is nearing the end of the line. And then I think the single-phase pad and three-phase problem is probably going to be a little bit painful for the next 12 to 24 months. But then I think we're going to get to a period of stability. And again, maybe we learn something from this as a country, right? Maybe we learn about the importance of having U.S.-based manufacturing. Maybe it's important that we learn the importance of planning and coordinating activities. Because, again, many of the factors that we talked about that changed the demand cycle, I think some of them were a little bit maybe premature. And if we were a little bit more thoughtful and we recognized, the state of our infrastructure and what it was going to take in order to support an economy or to support an energy policy that was changing so dramatically, we could have avoided this. We could have gotten in front of it, and we could have seen that, boy, oh boy, distribution transformers is going to be a pinch point, or conductor is going to be a pinch point. How do we build up that capacity in order to support an overall morphing of our infrastructure? I think we learn, and I think we do better next time.
I guess final question for you on the technology side. Obviously, transformers it's a mature market with tried and true and proven technologies, but there's always a next generation, a next thing to do. You mentioned using amorphous steel. It's more efficient despite all the challenges with getting it ramped up in the supply chain and so on. What else do you see on the horizon that you think is promising? People talk about solid state transformers and all sorts of other things. What to you seems like it might have legs as the sort of next generation transformer platform?
People have been talking about a solid state transformer for quite some time. I think there's some good proof of concepts out there. I'll tell you that, one of the technologies that that ERMCO has been working on through our GridBridge subsidiary has actually been put into test into Europe right now. We call it the low voltage engine, or the LV engine program. Yeah, so we're spending a lot of time thinking about power electronics and how we could use that technology to better control flow of electricity through a transformer and create a more efficient overall experience. So I think we're years out. It's a more expensive technology right now just because of adoption. But in the long run, I think if we continue to invest, there could be some fruit on those trees.
You talked just a little bit more about what that might look like. Like, imagine it works. What does that enable?
So one of the things that it would enable is a consistent voltage coming out of the transformer. There's a lot of noise in the electrical system, and with power electronics, you could continually dial in that level of voltage. If you think about maybe some of the challenges that we've had during winter storms, right, when all of a sudden demand peaks really high, if you could use power electronics to dial back electricity consumption, right, output through the transformer by 3 to 4%, still within specifications of what will allow the load to operate, but you take that across the entire grid at the same point in time, it's basically the same as producing 3 to 4% more energy. So if you think about that, that could be game changing in a period where peak load becomes a problem. I think that's one of the best applications.
Well, Tim, really appreciate the time here. Hopeful that the lead times and the prices start to decline in the distribution transformer market sometime in the near future. I've seen enough companies that has been the long pole in every tent for a company that needs distribution transformers. So I wish you the best in expanding your capacity.
Shayle, thank you very much for that. And again, a quick shout out to everyone that has worked their tails off over the past 3 years to try to close that supply and demand gap at ERMCO. They've done a great job. I know I wasn't supposed to say anything like that, but it's hard not to recognize the men and women that have busted their butts to make sure that the utilities could get what they need.
Appreciate that.
All right. Thank you much.
Tim Mills is the CEO of ERMCO. This show is a production of Latitude Media. You can head over to latitudemedia.com for links to today's topics. Latitude is supported by Prelude Ventures. Prelude backs visionaries accelerating climate innovation that will reshape the global economy for the betterment of people and planet. Learn more at preludeventures.com. This episode was produced by Daniel Waldorf. Mixing by Roy Campanella and Sean Marquand. Theme song by Sean Marquand. I'm Shayle Khan, and this is Catalyst.